My name is Ellen Shiner, and we want to welcome you to the Bedford Lyceum. The Lyceum is a free monthly lecture series for the greater Bedford community, made possible by First Parish in Bedford Unitarian Universalist. And before we introduce this afternoon's speaker, we have a couple of announcements. Today's presentation, as is true with all of the Lyceum, is being recorded and will be made available later this week on Bedford Cable TV and YouTube. If for any reason you do not want any comments you made during our Q&A session later included in the published recording of the presentation, please contact me. And if you go to the next slide, please, Paul. My email address is on the bottom here, mountainbreeze52@gmail.com. And I'm going to reference my notes. Okay, so our speaker today is Dr. Robert Stowe, Dr. Robert Stowe, Director of Harvard's Project on Climate Agreements and Executive Director of the Harvard Environmental Economics Program. Rob earned his master's in physics from Harvard and a PhD in political science from MIT. For more than 25 years, he has worked in the academic and nonprofit sectors with a focus on climate change and energy policy. Rob has participated on numerous international panels, such as the Climate Change Expert Group, hosted by the Organization for Economic Cooperation and Development in Paris, and conferences of the parties of the UN Framework Convention on Climate Change. Rob has also consulted for the World Bank and other organizations regarding agricultural management projects worldwide. And you might appreciate that Rob is not only a practitioner, but a certified teacher of the Transcendental Meditation technique, and has done so for more than 45 years. So it's my pleasure to welcome and introduce Dr. Robert Stowe. Thank you so much, Rob, for joining us.
Thank you, Ellen, for the kind introduction. And I always appreciate being mistaken for Rob Lowe. Thank you as well to my old friend, Irene Gravina, for her role in having me invited, and to all of you for attending, and to the parish as well for putting on this program. I'm going to share some slides, and there are a lot of slides. I'm going to go over the first 3/4 of them very quickly as background on what climate change is, and then talk a little bit about why it's such a difficult problem at a little more length, and we can, of course, continue during the discussion. Feel free to interrupt if you have a question. I think there are few enough people so that you can just unmute and speak out, but if you want to raise your hand, I'll try to keep an eye out for that, and maybe Paul can help me. Good, so let me share my screen. What is climate change? Climate change results from light coming in from the sun, which warms the Earth's surface. So visible light coming from the sun passes through the atmosphere with no difficulty. Once it heats the Earth's surface, light is re-emitted in the infrared range, a longer wavelength. And that infrared light does not get through the atmosphere so easily. In fact, carbon dioxide or CO2 and other gases block infrared light, trapping the heat near the surface. Here's a diagram that kind of illustrates that. It's kind of like a greenhouse, an actual greenhouse. Not exactly, but kind of. Close enough for now. What would the Earth be like without the greenhouse effect? Anyone? Quickly? If there were no, if
it would
carbon,
be frozen.
It would be freezing. Yeah, that's right. It would be, life would not be possible as we know it anyway on Earth if this phenomenon were not happening. In other words, if CO2 and other gases did not trap infrared light, we wouldn't be here. But it's a delicate balance between too little and too much greenhouse gases, especially CO2 in the atmosphere, as we'll see. Now, when we emit greenhouse gases, we human beings, from power plants and other sources, that results in higher concentrations of greenhouse gases in the atmosphere, which, as we just saw, results in higher temperatures at the surface of the Earth. And these higher temperatures cause damage to society, the environment, the economy, to oceans, and everything, pretty much. So emissions are the start of the problem, emissions of CO2 and other greenhouse gases. Now, since the 1850s, which was the Industrial Revolution when we started burning a lot of coal as a human race, humans have emitted increasing amounts of greenhouse gases. And here we see annual greenhouse gas emissions starting from 1750 going more or less to the present. As you can see, the amounts have been rising spectacularly. This is just CO2, by the way. If the high point is 35 billion tons per year, if this included all greenhouse gases, it would be more like 50. Where do these emissions come from? Well, about 3/4 come from energy production, which means burning fossil fuels. Another 18% or so comes from agriculture and forestry and land use changes separately from burning fossil fuels. Another 5% comes from industrial processes, again, separate from burning fossil fuels, especially cement manufacture. And then waste-related emissions cause a little bit. There's methane that comes from some waste processes and so on. Concentrations have risen from 280 parts per million to 413 parts per million now. So, it's approaching a doubling of the concentration. Here's a graph of the concentrations now, not the emissions, starting again from 1740, showing again a current level of around 413 parts per million. And don't mind the parts per million, just look at the relative increase from what it was to what it is now. A spectacular rise in concentrations in the atmosphere. And here's a graph that shows concentrations over the last 800,000 years. So you see these, variation. There are bumps and there are valleys, right, over long time spans. But look at the line on the very right-hand side, right here. So here's kind of the peak over the last 800,000 years, and then it goes way up here, very, very recently in these geologic times. So what we're doing now is an experiment that hasn't been tried for at least 800,000 years, probably longer. Now, 414 parts per million equals 0.0414%. So there's not much carbon dioxide in the atmosphere. The absolute quantity is very small. It's a trace gas, a scientist would call it. But what matters is the relative amounts. If you double that amount, it's going to cause a lot of warming at the Earth's surface. Now, climate change is what an economist or an environmental scientist would call a stock problem, not a flow problem. So what really matters is the concentrations in the atmosphere, not how much we're emitting in any one year. So it's the concentrations that matter. Now, obviously, the emissions cause the concentrations to increase. And that's what we have control over for the most part. So we do want to reduce emissions. Now, as I said, increasing concentrations cause rising temperatures at the Earth's surface, or what the climate change community calls global average surface temperature. And here's a figure showing the increase in global average surface temperature since about 1880. You can see it really got going around 1980, but since then it's increased a lot. So you probably have read in the newspaper or heard, in reports that many scientists feel we need to keep the increase from pre-industrial times to 2 degrees centigrade. well, the temperature has already gone up 1 degree centigrade, so we don't have a whole lot of space.
Rob, I have a question.
Sure.
Is the concentration of carbon dioxide cumulative? In other words, does it dissipate from our atmosphere eventually, and it's just slower than our emission rate?
Excellent question. And I was glossing over that for time, but it's an excellent question. Basically, it's cumulative, but then it's not. So CO2, one of the problems is that CO2 has a very long residence time in the atmosphere, measured in hundreds of years. So it does come out of the atmosphere, but only very, very slowly. So there's that. The other thing is that some of the CO2 is taken up by the oceans. So it's not quite cumulative, but basically it is, to a close approximation.
Thank you.
No, there's one more caveat though. You know, we all learned about the carbon cycle when we were in high school biology, right? So CO2 is constantly cycling through trees, through the soil, through the oceans. So it's not like one molecule of CO2 stays in one place, but the net concentration in the atmosphere stays more or less, it more or less represents what we put into it. And then the rising temperature causes problems, causes extreme weather events, typhoons and floods. We've seen all this, fires, reduced and disrupted food production because it gets too hot for crops to grow well, reduced water availability in some parts of the world. So you've read about glaciers and snowpacks becoming smaller. Sea levels rise because land ice melts from Greenland and Antarctica. And also, there's another reason that sea level rises actually, which at the moment is more important, and that is that the warming Earth's surface causes the ocean water to expand. Water expands when it gets hotter, and that actually is the larger influence on sea level rise right now, though it may not be in the future. The geographical range of tropical diseases expands, which is a big problem potentially, and actually in some parts of the world. And also, when it gets too hot, human beings can't live in a particular place and they have to move. And for that reason, because water is less available, climate change generates conflict, violent conflict. And there have, been very thoughtful and well-reasoned papers on the role of climate change in conflicts in Iran, Syria, parts of Central America. Now, it's not that climate change is the only cause of violent conflict in those areas, but it really looks like it's been a contributing cause. Here's a diagram of sea level rise since about 1900. It's gone up about 8 inches on average around the world. Now, it'll vary from place to place for various reasons, but that's the average, which is actually a lot. Arctic sea ice coverage has gone way down. At the September minimum of Arctic sea ice, it's gone down from about 8 million square kilometers to about 4 million square kilometers, so about half of what it was around 1980. Impacts and damages are likely to be more severe in developing countries because they're already pretty hot, number one, and also because rainfall will be affected more in those areas. I don't have time to go into the reasons for that, but it does look to be the case. And I mentioned this about conflict. Now, so climate change is bad on the whole. Why has it been so difficult to deal with it? Any ideas? Yeah, just
Too many
Sabrina.
people don't believe.
Because a lot of powerful people and powerful countries and organizations benefit from the selling of oil and other fossil fuels.
It's definitely one reason. Anybody else? Yeah, Paul?
Because
by the way, when I say raise hands, you can raise your physical hand or your hand in Zoom if you know how to do it. Anyway, go ahead, Paul.
just it happens relatively slowly, and so that you can't see it day to day. It takes time.
Absolutely. I think that's a big reason, especially since in democratic countries such as ours, the presidential cycles are 4 years and the congressional cycles are 2 years, which are a heck of a lot shorter than the length of time over which climate change is occurring. Yeah. Any others?
We don't have a coordinated strategy.
Yes, and why? Any thoughts on why we don't have a coordinated strategy?
There's probably a combination of factors.
Yeah, probably a combination.
I would say that there are so many competing interests that it's very difficult to coordinate.
Goes along a little bit with what Sabrina said, yeah. And also Paul. Yeah, that's good point.
This is Dorothy. We don't have many alternatives, especially in February, if you've got to keep warm somehow, and that's gas, oil, got to do it some way.
Yeah, no, it's really true. We know what to do about climate change. This is in response to Dorothy's point. We know basically what to do about climate change and how to fix it. I'm being partly facetious here because it's difficult to fix it. But if 75% of the emissions are from burning fossil fuels, then the way you have to address climate change is to start using electricity for everything, including heating, and to generate that electricity from zero carbon sources, mainly renewables. But obviously that's easier said than done. And there are other parts of the problem that don't involve burning fossil fuels, and there are other things you have to do there. Any other points on why climate change is such a hard problem? A political scientist named Kelly Levin in 2012 called it a super wicked problem, which indeed it is. Sorry, go ahead.
Yes, this is Tucker speaking. I think it's a matter of scale, and many people shut down because they're overwhelmed. So as opposed to feeling empowered to work together to solve and create or mandate change, just shut down.
Excellent point. I didn't have that in my slides, but I should. Yeah, it's such a massive problem. You can only process so much. Yeah. Excellent. That's a good point. Others? Yeah, Peter again. Yeah.
In a related thing, I think people today have so many things to worry about in just their day-to-day survival that it's hard for people to think of something that is not going to be a big problem for them for the next 20 years when you have to worry about putting food on your table today.
That's a very fair statement, and then that's true for all of us. But imagine living in a poor country, in Bangladesh or in parts of India or other developing countries. You may well have and will have other priorities. Just getting electricity to your house and have it be on for most of the time is likely to be more important than worrying about climate change. You need electricity and lights for earning cash, for earning income, for your kids to do their homework, possibly to cook your food so you're not using firewood causing indoor air pollution, which kills you, and the like. So there are a lot of other priorities, especially in developing countries, than reducing emissions. And there's this also this vicious cycle in tropical countries where it's getting hotter and hotter. You're getting somewhat wealthier and able to afford air conditioning, which in turn causes more emissions. So air conditioning doesn't sound like much, but it's a big part of the problem. But are you going to say to people in tropical countries that, oh, well, we have air conditioning, but you can't use it? No, of course not. But so you need to find out some way to generate that electricity without producing emissions. So.
Meredith had her hand up.
Yeah, in some of the undeveloped countries, they're destroying the environment for economic reasons, particularly the poor ones, and that takes away from some of the natural reset that goes on with the environment. I'm thinking of the Amazon in particular.
Yeah, excellent point. Excellent point. So that deforestation is a big contributor to climate change. Not as much as burning coal, but it's a big deal. Because after all, trees are a huge sink for greenhouse gases, for CO2. So trees suck CO2 out of the atmosphere, right? And as they pull CO2 out of the atmosphere, they grow bigger. But if you cut down trees, as is being done in the Amazon, number one, they no longer are taking CO2 out of the atmosphere, so you lose that sink. But in addition, as they decay, they release other gases, which are greenhouse gases potentially.
We had a couple other hands raised, Luana and Ed Schwartz.
Hi, this is Luana Reed. At least in our country, I think one of the problems is also we can't agree on the facts. And if we can't agree on the facts, how are we possibly going to agree on a solution?
Yeah. So it's climate change is kind of collateral damage to larger divisions in our country. Yeah, that's right. Yeah. Good.
Ed?
This is Ed Schwartz, and I think also people are afraid of change. Even those of us who are plenty wealthy enough, there is a conservative attitude that we are wedded to the world as it is, in a sense. And when you say we're going to have to invest large amounts of effort, even if we're wealthy enough to do it, there is a resistance, a natural resistance.
There's a hand up by someone named Yellow. Screen name Yellow.
Yeah, that's me, Sam Gravina. My phone's name Yellow. I'm in the car, and so it thinks that's my name. Are you guys hearing me?
Yep, go ahead.
Yeah. Okay, so it's a very big problem. It's big in a lot of areas. The climate is very, very large. The amount of energy in the climate is just enormous, just in terms of joules of energy. The tools we have to manipulate it are much, much smaller. Like we can use less transportation or less heating or whatever. There's very little room for changing those things compared to the amount of change we want in the climate.
Thanks, Sam. A little hard to hear, but I think we got it. And in fact, if I may just progress my slide a couple, this is my second possible explanation for climate change being such a hard problem is the Earth is such a massive system. The whole atmosphere and much of the oceans are involved. So there's a lot of kind of thermodynamic inertia there. And in fact, if we as a planet were to reduce emissions to zero tomorrow, the temperature, the global average surface temperature would continue rising for quite some time and for quite a bit, probably another 0.5 degree from centigrade from what it is now if we stop tomorrow, which of course is not going to happen. So there's a lot of thermodynamic inertia in the system that's so large. I think this is sort of what Sam was saying. Anyone else?
This is Ellen. I was just thinking that it's a vicious cycle because we're being affected by climate change, and trying to address those urgent conditions like floods and fires takes away from addressing the long-term cause.
I hadn't thought of that. That's a really good point. You get caught up in the battles and you forget about the war, so to speak, if you don't mind me using that analogy. Terry?
There's a large school of economists, especially in Europe, but also here, that say our growing GDP economy is at direct odds with reducing our energy consumption and therefore addressing climate change.
I'm sorry, growing what kind of economy?
GDP.
Oh, GDP, yeah. Yep. I'm somewhat familiar with that school, yeah. There's that, I mean, that idea has been around for a while, not with respect to climate change necessarily, but other environmental problems. Wondering, you know, is growth really a good thing? And then how do you define growth? Should it be strictly in terms of production of goods and services and so on? Ellen.
Yeah, I think this has been said in other ways, but the upfront costs to build the infrastructure to use alternative forms of energy is so great right now that it's an impediment. So we go forward using the existing methods of burning coal and fossil fuels.
I think that's a good point. There is some good news, though, in that regard. As I think you know, Ellen, and most of us do, that the cost of renewable generation, that means building solar and wind, solar arrays and wind turbines, has gone down tremendously just over the last 5 years, and certainly over the last 20 years. So that's good news. And, you know, the amount of renewable generation is going up pretty rapidly, which is all good. There are problems still with, it's not enough, number one, but it is good. And number two, there are problems with building out a power grid that is capable of kind of handling that much renewable generation and actually getting the electricity from where it is, you know, on the plains of West Nebraska to where you need it in Chicago. But yeah, it's there are other, I'm going beyond renewables. If you want to get into modular nuclear power plants that are safer and so on, or fusion power, or, you know, other carbon capture and storage, taking CO2 and pumping it underground and keeping it there. Those are still very expensive. Are there other comments, or should I go through my own offerings?
Sabrina had her hand raised.
Okay.
It requires lots of action from like the government and regulation, and the US government does not like to take those sorts of big sweeping actions.
Excellent point. This is my my fifth reason why climate change is so difficult. So adequately addressing climate change requires government action, and there's a scientific reason for that. So, and I'll try to present it briefly. CO2, because it has such a long residence time in the atmosphere, will spread uniformly throughout the world's atmosphere. So if we have a power plant in Massachusetts that emits CO2, maybe it's a gas-fired power plant, that CO2 is going to mix throughout the global atmosphere. So while the emissions are local, the climate change it causes is global. Likewise, if the power plant in Massachusetts wanted to reduce emissions in some way, it would have to incur some cost for doing so. It would cost something to change the way it generates electricity or capture the carbon dioxide somehow. That cost would be incurred locally, but the benefit of reduced damages from climate change would be spread all over the world. So there's no incentive, concrete incentive or financial incentive for that power plant to reduce its emissions, because it won't be able to get back the cost it puts out to reduce emissions. So because CO2 spreads evenly throughout the atmosphere, you have what an economist would call external costs, or a global commons problem. And for that, you need government to get involved, because there isn't an incentive for individual emitters to reduce their emissions. And there are some groups and individuals. Number one, it's hard for government to do this, just because it's such a big problem, as someone mentioned earlier. But secondly, there are some groups and individuals, certainly in our country, that have an ideological commitment to minimizing government intervention in the economy. So they resist doing anything about climate change, even though it is a global commons problem and requires government action. And sometimes even discussing climate change, because once you admit that it's real, then logic leads us to the conclusion that government has to do something because of the physical nature of the problem. It also requires international cooperation as well, which I'll mention briefly at the end. That was great, Sabrina, thank you. Anything else?
Don't see any other hands raised.
Let me just go through my slides, and a lot of this now will duplicate what you've already said, which is great. So this one, I don't think anyone mentioned. Part of the problem is that the causal chain that I described above, so that means emissions to concentrations to increased surface temperatures to damages or harm caused by climate change. That's a statistical or a stochastic causal chain. You're talking about average surface temperatures. You're sampling the temperature at the surface of land and ocean over tens of thousands of locations, and using very complex algorithms to process that data and spit out a single number. You're talking about divergence of temperatures this year from a mean, usually a decadal mean. When you're talking about extreme weather events, you can't say that this hurricane or this fire or that typhoon was caused by climate change. You can only say that climate change has increased the probability of such a typhoon by X%, or this fire by X%, if you can say that. You can certainly say that climate change has increased the probability of a variety of extreme weather and other events. Fire isn't really a weather event. And sometimes you can say by X amount, but you can't say that climate change caused Hurricane X. And if anyone does, then they're misleading us. Compare, when you're talking about gravity, it's strict cause and effect. You know, there's this force that's acting on this body, this ball, and it's going to accelerate this ball by a very specific amount. It's not probabilistic. Now, it's hard for humans, including me, to think in terms of statistics all the time, but that's what you have to do if you want to really understand what's happening to the Earth as a result of climate change, and that's hard. And when you try to talk about it, people, including me, again, myself, start to get a little fuzzy in their brain. And when you get fuzzy in your brain, it's harder to do something about it. I've never been good at statistics. What has been mentioned is that climate change unfolds over long periods of time. I talked about the Earth's physical system and that CO2 has a long residence time. So this is a very long-term problem. On the other hand, so how do we make decisions about the distribution of costs, benefits, and suffering over many generations and hundreds of years? It's very difficult for us to do that as human beings and as societies. Third, there's still some uncertainty about climate change. Now, there's no uncertainty about the direction of that causal chain. Those are all plus signs. So in other words, more emissions causes more concentrations, causes more higher temperatures, causes more damage. That's for sure. But there's some uncertainty, especially with respect to the impact of concentrations on temperatures. In particular, the so-called climate sensitivity, which is a term that climate scientists use to refer to the doubling of concentrations. The impact on global average surface temperature, the likely impact ranges from 2.5 to 4.5 degrees C, which is a pretty wide range, and it's been hard to narrow that. It has been narrowed some recently, but it's still a pretty wide range. And there's a big difference in the damages between 2.5 and 4.5 degrees C increase over pre-industrial times. Also, there's remaining uncertainty about how climate change affects specific regions, countries, and localities. It's almost all adverse, but what are the specifics for Congo versus Mexico versus Kansas, versus Greenland? We've gotten better at kind of being specific about the impacts of climate change, but there's still uncertainty. Next, and there were references to this in your comments, thank you. 75% of emissions comes from burning fossil fuels, and the energy economy pervades all aspects of society and our lives. So that makes it difficult and costly to reduce emissions. Now, try to tell me one thing you did today that didn't involve either directly or indirectly burning fossil fuels or using energy in some way, including electricity, that did not involve using any energy. It's hard. Hard to think of one.
Well, humans use energy, and we get energy from food, which we get from agriculture, which also produces greenhouse gases. So,
exactly.
Question.
Excellent, Sabrina. Yeah, very, very good point. So a lot of modern agriculture uses fossil fuels for tractors and machines and stuff. And plus putting into chemical fertilizers that uses fossil fuels as well, for the most part. Yeah, can you think of anything you did today that you didn't use energy?
In the chat, we have one suggestion, which is gardening.
Okay.
Meditating.
As Sabrina said, we need food for anything. But yeah, other than that, sure. Yeah. I mean, your tools are probably made of steel, at least or in plastic, and you needed a lot of energy to make the steel. Great article in the New Yorker, by the way, 1 or 2 issues ago about producing green steel in Sweden, if you have a chance to look at that. The plastics are made from petrochemicals, which come from oil. So it's hard to think of anything we do that doesn't use energy. So I think someone said earlier that this is a very complicated problem that pervades every aspect of our life. And that's largely because we have to completely revolutionize how we produce energy. And that, that kind of seeps into everything we do and everything, that surrounds us. So it's very difficult in that respect, challenging. Here's a great diagram. I'm not going to go into it in detail, but on the left side, you see fundamental, the word's escaping me, the basic sources. I'm sorry, you see the sector that might be using energy. And then the end user activity, and then the greenhouse gas that it produces. And suffice to say, again, that every sector almost is involved, and it's very complex. So it's hard to change. I talked about that one. Finally, one thing no one mentioned, but it's kind of interesting is, if you're looking at sulfur dioxide, which is produced from a coal-fired power plant, and it causes respiratory problems, adversely affects health quite a bit. It's a local pollutant. In other words, it doesn't affect the whole world. It affects some area around that coal-fired power plant. That SO2 would not be there in the atmosphere if it weren't for that coal-fired power plant. So, it's pretty clear cut that it's a bad thing, that it's coming from the power plant. And if the power plant weren't there, we wouldn't have the SO2 and the health problems that come from it. Is that true of CO2? No, right? I mean, CO2 is essential to life on Earth. There's the whole carbon cycle. Of course, plants breathe in CO2, then they breathe out oxygen, and we do the reverse. CO2 is essential for other biological processes in the ocean and so on. It's certainly there, and we need it. But it's just that a little too much of it causes big problems, and we're putting a little too much of it. It's actually a lot, but relatively in absolute terms, it's a little into the atmosphere. And that's hard to get your head around. In fact, there are a lot of climate skeptics who say, what are you talking about? CO2 is not pollution. CO2 emissions is not pollution. And in fact, it's going to make the world better. Plants are going to grow more. We're going to get more food. It's all going to be good. Why are you worrying so much? And it's actually a little bit tricky to respond to that argument, right? The response is that sure, but the warming that's caused from too much carbon dioxide, specifically concentrations that are too high, the damage from that is going to far outweigh any benefits to plants growing a little more quickly. But that's a little bit of that argument is a little hard for us to process. So that's what I had to say about why climate change is such a hard problem. I hope it was your comments certainly were very helpful, and in some cases new to me. I might revise these slides as a result.
Well, thank you so much, Rob.
I did have a couple more comments.
Sure,
just
please.
not on this, but I was pausing to see if anyone had anything else on this.
Sorry.
Well, I just one comment.
Yeah.
With, the people who say that a higher CO2 concentration could have some benefits, so perhaps if humans had evolved with, carbon dioxide at 400 parts per million in the atmosphere, we would have adjusted over hundreds of thousands of years and we would live in different places. But that's different from adjusting in 20 years or 50 years.
That's an excellent point. Thank you. Yeah, and well taken. Ellen, I hope it was okay. We kind of mixed the discussion in with.
Oh, no,
Yeah.
this is fine. This is
Okay.
great.
Good. And we have until 4?
Yes.
Yeah. So
Yeah, from 3 to 4. Yeah, so we thought we could open up to Q&A, but I want to just thank you very much for such an informative and thought-provoking.
if I may take just one more minute.
Yeah, yes, please.
I mentioned international cooperation because climate change is a global commons problem. There's no world government to tell you to reduce emissions, so countries have to cooperate. And of course, the main vehicle for that is the UN Framework Convention on Climate Change, which produced the Kyoto Protocol and the Paris Agreement. Here are the principles in 2015 in Paris celebrating the adoption of the Paris Agreement. There's the Paris Agreement. I'd love to talk about it more. We don't have time. I've taught courses on the Paris Agreement at the Kennedy School and so on. But that's all I wanted to say. Please, any Q&A.
Peter had a question.
Rob, you haven't said anything about technologies to remove carbon from the atmosphere. And I saw an article recently in a reputable place that said there is a certain moral hazard to thinking we can fix this by taking the carbon out. But on the other hand, we can't, there's no way on earth that we can solve the problem without making that part of the solution because we're too far gone already.
Excellent question. And I'm madly thinking how to respond briefly. But yes, taking carbon dioxide, maybe other gases, mainly carbon dioxide out of the atmosphere has to be part of the solution because we're never gonna stop, level out concentrations early enough. So now trees and other plants and maybe soils actually are good ways to do that, kind of natural carbon dioxide removal. But then you have technologies that certain companies and people are, including one of my colleagues at the Kennedy School, are using to suck carbon dioxide out of the atmosphere. That's currently very expensive, but I think we have to keep investing heavily in bringing the cost of CO2 removal down. And then maybe in 50, 70, or 100 years, it'll be deployable on massive scales to kind of bring the concentrations back down again after they've gotten too high. I don't know if that answered the question, but the moral hazard. Sorry. So yeah, which means we might deploy CO2 removal on a large scale, and then everyone says, "Oh, we don't have to reduce emissions anymore because we're okay." So that's what is meant by moral hazard. And yeah, there's a danger of that, but people used to say that about adaptation too. So adaptation to climate change means that we have to do various things to accommodate ourselves and our societies, our cities to climate change. And we do, because we're not going to be able to stop it in time without adapting, so that we don't have to adapt. But people used to say the same thing, that talking about adaptation constituted a moral hazard, because if we can adapt, why should we reduce emissions? So yes, no, it's true. There is a danger of that. Good question.
Luana?
You showed us a slide showing the carbon dioxide buildup really getting going in the 80s. Is there anything that happened around that time, or in the 20 years before that triggered it?
Yeah, Luana, that was the temperature, actually, not the concentration.
The temperature. I'm sorry, but
the concentrations were building up earlier than that.
Okay.
But emissions did keep growing and growing, which means that concentrations grew faster, starting in the 50s, certainly. But then temperatures took a little longer because there's a lag time between
okay.
increased concentrations and increased temperatures. Yeah, which is
Also-
why I said if you went to zero emissions now, the temperatures would keep increasing for a while.
And is there also a correlation with human population growth?
Sure, I mean, the more people you have, the more emissions you tend to have, right? Because
Yeah.
there are more people using energy.
Rob, there's a question in the comments.
Yeah, so local action. There are things we can do. I think the most important thing that we can do as individuals is help get, in our country, to help get people elected who want to do something about climate change. That's number one. And I speak as someone working for a nonprofit organization, so I can't, recommend any particular political party or so on, but look at, how to figure that out. Number two, some of the problem is local. So it has to do with city planning, town planning, organizing our lives so that we don't have to use cars as much, designing our cities to be greener, literally and figuratively. So a lot of the emissions that come from transportation and from buildings can be affected locally through ordinances, zoning, and the like. So those are sorts of things that we can affect locally. Electricity generation, it's a little harder to affect locally, but you can buy, there are ways to buy electricity that's produced through renewables, through your utility company and so on, which is one way you can kind of nudge that process along. Also, you can buy electric cars. I haven't done it yet. I'm going to, soon as my cars are fully depreciated. But you can, move by heat, start, if you can, if you're able to, start heating your house with heat pumps, mini split systems and so on that use electricity rather than gas or oil. So those are some of the things we can do as individuals. I'm sure none of those were new to you, but it's a list. Are there other questions? Go for a walk. Oh, okay, but this is back to like, what do we do that doesn't require burning fossil fuels? One person said meditating. All right, that's a good one, which I do.
Dorothy had a question.
Yeah, I have lost track of where we are in the nuclear discussion of nuclear power. As far as I know, it's still the conundrum of it has great potential, but no one's figured out what we're going to do with all of the nuclear waste and the hazards of these plants. I wondered if you had any thoughts on upcoming changes in technology that might move that along for our benefit.
I've thought a lot about it, and people I work with have thought even more. And I've thought enough about it so that I can distill it pretty well. Nuclear power means fission power, the sort of power that we're used to having for a while, is wonderful in the sense that it has no greenhouse gas emissions, but it has a lot of other problems, including getting rid of the waste. Now, there's so-called new nuclear, new types of power plants that could potentially have less waste, be safer, be less prone to people, bad people stealing the fissionable material and so on. But it's still a long way off. And the other thing is that nuclear power is very expensive. So it's just not competitive financially right now. One thing I'm excited about is fusion. Now, fusion is like carbon dioxide removal from the atmosphere. It's a long way off, but there was just a big breakthrough at MIT. And I don't have time to describe it, but it was a big, possibly massive technological breakthrough on fusion, which may result in a power plant in 5 or 10 years that breaks even. So it produces more energy than it consumes. I think that over the longer period of time, it's possible that fusion will be a big part of the answer. And it does not have the waste problem, does not have the proliferation problem. It does not have the safety problems that fission power does.
There are several questions in the chat.
Oh, one last thing on nuclear. I do feel very strongly that we need to keep the nuclear power plants that we already have for the duration of their useful and safe lives. So in other words, I don't think we should prematurely retire the nuclear power plants we have, because they give us a lot of space, carbon dioxide wise, to try to address climate change. Sorry, go ahead.
There are several questions in the chat you may want to take a look at.
How do you address the issue that the richest 10% are responsible for 50% of greenhouse gas emissions? Well, partly through tax policy. You tax the rich more and use the money for addressing climate change. That's one way to do it. I mean, it's hard, at least in our country, to say, you can only build a house that's so big. No, again, zoning and so on can affect that. But I think the most straightforward way is through tax policy. The previous question, any recommendations for someone looking to go into a career where she might make an impact on climate change? And this is from Jen McLean. Well, I'm not quite sure where you are in your career, Jen. It's really good to get a good grounding in science and mathematics. And that's useful whether you plan to go into the natural sciences, like atmospheric chemistry, or the policy sciences. For example, going to the Kennedy School where I work to get a master's degree. That'll be useful to you. If you're later in your career, there are short courses you can take. We offer executive education courses, for example, kind of to get you changed over to focusing on climate change. And I'd be happy to talk with you separately in more detail if you want. Just let me know.
There was a question in the chat. How does one fight groups like American Petroleum Institute?
That goes back to what I suggested was the best way we as individuals can address this problem, which is elect representatives who want to do something about it. And that's how you fight the API. So it's hard to fight them directly. Of course, we're already in pretty good shape in Massachusetts.
Yeah.
You have to move to Pennsylvania or like Nebraska or something and start working there. But I'm partly kidding. Any other questions?
Again. Anybody else with a question though before we close? Well, this has been great. It's really thought-provoking. I'm so glad we had so much participation from all of those on the call. It's been terrific. So thank you, Rob. I just had a couple of slides. If you could switch over, Paul, to slide 4, or I'm sorry, 3, that would be great. I just wanted to share that we have a couple of Lyceum presentations coming up that should be pretty good. Alan McRoberts from First Parish in Bedford is going to speak about the search for intelligent life in the universe. He's from Sky and Telescope magazine and will speak about life in the universe. So where are they? And Brad has a musical program coming up, yet to be titled. That should be really enjoyable in December. We're always looking for suggestions for speakers. So if you have ideas, please feel free to contact me at mountainbreeze52@gmail.com. And Rob, if people are interested in reaching you, would you like them to go through me, or do you want to supply any information on your contact information for yourself?
No, feel free to contact me directly, and I will try to respond as quickly as I can. I have a lot going on, but I will respond. Here's my personal email address, which I think in this case is better than my work address.
So for those who are just listening, it's rob.stowe, S-T-O-W-E, @gmail.com. Thanks, everyone. The last slide, I just wanted to thank Paul for being our Zoom guru this afternoon, and Bob Batt, who's going to be our YouTube wizard, and to the rest of our super technical staff. Have a great afternoon, everyone. Thanks for joining us. Bye-bye.